Hello student, I am Dr.A.K. Today I am going to discuss empirical formula and molecular formula. First I will tell you what is the empirical formula. Empirical formula represents the simplest whole number ratio of various atoms present in it. In the compound, I am telling you what is the empirical formula. This is used for the compound. An empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different type of atoms present in a molecule of a compound. Both are different. Empirical formula and molecular formula is different. Empirical formula tells about the whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. If the mass percent of various elements present in a compound is known, its empirical formula can be determined. Means mass percentage you must know. If mass percentage is known, then empirical formula can be calculated. Molecular formula can further be obtained if the molar mass is known. Now I will tell you that steps how will you calculate empirical formula and molecular mass. Both are actually related. If empirical formula you are knowing and molecular mass you are knowing, then you can calculate the molecular formula. Now I am telling you how will you calculate the empirical formula and molecular formula. There are total 5 steps. Then 4 steps you will use to get the empirical formula. 4 steps you will use to get the empirical formula, and 5th step you will use to calculate molecular formula by use of empirical formula. Then step 5 again it consists of 3 steps that I will tell you. First just I will give one example, and after that I will explain. Question I am telling. First I will read the question and then I will explain the all steps. As for example, that I am telling the question, a compound contains 4.07% hydrogen, 24.27% carbon and 71.65% of chlorine. Its molar mass is 98.96 gram. What are the empirical and molecular formula? This is the question, and only same type of question is asked in so many examinations from the university level to IIT level, medical, and even the higher they will not ask up to IIT. Then now here in question percentage of hydrogen, carbon and chlorine is given, and molar mass
homogeneous mixture
is given. Now you have to find out two things, empirical and molecular formula. Then now I am telling you how will you get empirical formula. Then 4 steps first to apply. Then here first of all it is very easy to calculate. Actually hydrogen percentage is given,
along with some
carbon percentage is given, chlorine percentage is given. Then percentage means out of 100. Suppose total is 100 gram. Then in that 100 gram, 4.07% is carbon, means 4.07 gram carbon is there. 24.27 gram, 4.07% hydrogen is there. 4.07 gram hydrogen is there. 24.27 gram carbon is there, and 71.65 gram chlorine is there. Okay, that you have taken in gram. Then now you are knowing that hydrogen is 4.07 gram, carbon is 24.27 gram, and chlorine is 71.65 gram. Then now this, after that what you have to do, that is the second step, you just convert it into the mole. Then how will you convert into the mole? Then you know weight divided by atomic weight is equal to mole. This is the formula. Weight divided by atomic weight, that is equal to mole. Then here hydrogen you have to convert into mole. Then 4.07 gram divided by 1.008. It will come 4.04. That is the mole. Mole of hydrogen, now it came 4.04. Similarly, moles of carbon you can easily convert. That is the carbon, carbon weight is 24.27 gram. Then this you divide it by, you can say atomic mass of carbon, that is the 12 gram. You know, then 24.27 divided by 12.01, then it will come 2.021. This is the number of moles of carbon. Then now you have calculated. Third one, that is the moles of chlorine. Same way you can calculate. Then 71.65 gram chlorine is there. Then now this you divide it by atomic mass of chlorine, that is the 35.453. Atomic mass of chlorine is 35.453. Then now after solving, this will come 2.021. Then now you got the number of moles. Number of moles of hydrogen, number of moles of carbon, number of moles of chlorine. Now you have determined. Then now result, if this moles if you will see, then it is coming in a fraction. Like this mole of hydrogen has come 4.04, mole of carbon has come 2.021, and mole of chlorine has come 2.021. Then now what you have to do, what is the list number, list. Then from that list number, out of this three, which one is list? Then 2.021 is a list. Then now just divide all number by list number.
And oxygen gases
Now list number you divide by all number. Then you will get a simple ratio. As for example, now divided 4.04 is there, then divided by 2.021. Okay. Now next again 2.021 is there, divide by 2.021, then it will come automatically 1. And third one also 2.021 is there, again you divide by 2.021. Means all you have divided by it, least number, that is 2.021. Then you will get you can say value like 2, 1, 1 means now you got the ratio 2 is to 1 is to 1. This is actually third step. You got the ratio 2 is to 1 is to 1. This you got the, you can say, ratio. Now this ratio 2 is for hydrogen, 1 is for carbon, and again next one is for chlorine. Then in fourth step, just simply this number you write with atoms. Atoms are elements, different elements. Then you can write C. Actually got the value like that, 2 is to 1 is to 1. It means now you can write 2 is for H
quantities
and 1 is for C, again 1 is for Cl. Then you will get the, you can say, empirical formula. You will get like C H2 Cl, C H2 Cl, because C is you got 1, for the C you got 1, for H you got 2, again for Cl you got 1, hence empirical formula you got now CH2Cl. Okay, then this is called empirical formula. This ratio what you got, for the hydrogen you got 2, for carbon you got 1, for Cl you got 1. Then simply you just write that number with this atom. Then for the carbon 1, for the hydrogen 2, and for the Cl 1. Hence you got the simple, you can say, empirical formula. You got CH2Cl. This is the empirical formula of the given compound. This is empirical formula. Now from this empirical formula you have to find out the molecular formula. Now in this step, this fifth step consists of 3 steps. Then now what are the 3 steps? That is also very easy. First, what you got empirical formula, now you put the atomic mass of these atoms. Then you will get empirical formula mass. You will get the empirical formula mass. As for example, you got the CH2Cl, then you put C means 12, H2 means 2 into 1.008 plus 35.5. Cl is there, 35.5. Then what you will get, if you will add all, you will get 49.48. Then this is the actually empirical formula mass. Just simply, just like molecular mass, you are calculating same way. Carbon atomic mass of carbon you write, and this atomic mass of hydrogen into 2, because here is 2 hydrogen, plus chlorine, only 1 chlorine is there, then 35.5. Then add it all after multiplying, or add it all, then you will get 49.48 gram. That is empirical formula mass. Now second step in this, this molecular mass is given. In question, molar mass is given, that is 98.96. Now you got you have calculated just now empirical formula mass. You have calculated empirical formula mass just now you have calculated, and molar mass is given. Molar mass is given in question. Then now actually you have to find out a small n value. What is that small n value? Then this is the this value you will get when you will divide molar mass divided by empirical formula mass. Molar mass divided by empirical formula mass. Then whatever value will get, that is called a small n. Then here molar mass is given 98.96 gram, and empirical formula you have calculated, that is the 49.48 gram. Then 98.96 divided by 49.98, you will get roughly 2. You will get roughly 2. That is called n, small n is equal to 2. Here I want to tell you, suppose you are getting not exactly whole number. Here suppose you are getting 2.1. Then bring it nearest whole number. If suppose you are getting 1.98 or 1.99, then you write approximately 2. Suppose you are getting 3.01, then write 3. If you are getting 2.97, then you write 3. Means nearest whole number you have to write. That value is called a small n. And third step in the fifth, that is the last step. Now this number whatever you got, here you got 2. Then you multiply empirical formula with this 2. Then you will get molecular formula. Then here empirical formula was CH2Cl, and a small n value you got 2. Then molecular formula will be just multiply by 2, means C2H4Cl2. C2H4Cl2. Then this is the actually molecular formula. This is done actually, it is multiplied by n to bring the formula in a whole number, not in fraction. That's why n is required, a small n is required, so that molecular formula should be in the whole number. Now I have discussed about the empirical formula and molecular formula, and these are very easy. So total 5 steps are there. In that 4 steps are used only to get the empirical formula, and last step is used to get the molecular formula. To get the empirical formula, percentage is required, then percentage will be given in the question, then out of 100 that gram is given, percentage is given, means out of 100 that gram is present. Then second step, just what are the, you can say, value, gram means value of different atoms divided by atomic mass of all atoms. Then you will get a value. That values are ratios. Then that values, again what you got, just you divide it by the list value. What you got different values, in that which one is list, from that you divide all, then you will get a simple ratio. Here I give an example, you will get 2:1:1. Then now this number, just simply you write formula for, as for example you got for hydrogen you got 2, then H2, you got for carbon 1, then C1 or only C, or for chlorine 1, you got 1 value, then write 1 or only C, means you will get H2Cl, means C, you arrange it, CH2Cl. This is the empirical formula. And then for the for molecular formula, again 3 steps are there. Then first, this empirical formula, just you convert into the empirical formula mass, just like this molecular mass calculation, same way. C, as for example, CH2Cl got, then put the atomic mass of all for carbon, for hydrogen, from chlorine, and then you will get empirical formula mass. After that, when you have got the empirical formula mass, next step, divided by the molecular mass, given molecular mass in the question, then you will get the whole number. This whole number, suppose here you got 2, then you multiply molecular formula with this number, as for example 2, then you will get the molecular